grades. Quadratics Part 3, from basics to grade 9. In Part 3, we're looking at extended problem solving. This means that we will be looking at disguised quadratics, quadratics with geometry, the discriminant, and multi-step problems. So by the end of this session, we are going to be able to use substitution to reduce quartic or other disguised forms to a standard quadratic. Secondly, we're going to combine geometry. Here we're going to apply quadratics within Pythagoras, circle, and perimeter stroke area problems. Thirdly, we're going to reason algebraically, which means we're going to use the discriminant to prove the nature and number of roots. We're also going to be looking at how to tackle multi-step problems. Here we are going to sequence several quadratic techniques within a single extended question. Concept number 1, quadratics in disguise. So this is where we're going to apply substitution. Here's the examiner tip. You're going to spot pattern first. If one power is double another, let u equal the smaller power to reduce it to a familiar quadratic. So we got two problems here. Let's get started with the first one, where you got x to the power of 4. So, and then the other one has got x to the power of 2. So you can see that we can halve these powers. In that case, we're going to say, let u be equal to x squared. So what that means is the original equation becomes x squared to the power of 2 minus 5x squared plus 4 equals to 0. So you can see I'm making way for u to come in, and then it brings this to an equation which looks much simpler than the original one. Now we go to look for factors of 4. And factors of 4 are easy to find. So 4, 1 and 4, and also 2 and 2. In that case, to be able to get positive 4, that means plus 1 times plus 4, or negative 1 times negative 4, plus 2 times plus 2, or negative 2 times negative 2. Now in that case, we need to get negative 5. So negative 5 can only be obtained by taking negative 1 and negative 4. So now we will be able to factorize. We're going to write u within those brackets, and then we are going to combine that with minus 1 and minus 4. This gives us either u is equal to 1 or u is equal to 4. Let's bring back x squared. So remember, x squared equals to u. So x squared equals to 1 or x squared equals to 4. And then x is the square root of 1, and that gives us plus or minus 1. And x on that side is the square root of 4, that gives us plus or minus 2. So these are our solutions. So x can be plus or minus 1, or x can be plus or minus 2. So these are our solutions for the first question. Now, in question number 2, we got to work the other way around, because the starting point for us is the square root of x. So in that case, what we're going to say is, let u be equal to the square root of x. So if you want to do the square of u squared, that gives us x. So you can already see that this one is going to be u squared. So let me write this first so we can make sense out of this. Okay, so as we said, x now becomes u squared. So 2u squared minus 5 square root of x is replaced by u plus 2, and that becomes to 0. And you may remember that here we have to use the AC method, because here we haven't got a 1, we have got a number other than 1. So the AC method, so AC is, remember, A times C. In that case, you're going to have 2 times 2, which again, as previously, you got 4. So the factors of 4 are 1 and 4, 2 and 2. And in that case, we're still looking for a negative 5. So we worked it out. So it was going to be minus 1 minus 4, which gives us minus 5. Therefore, we're going to write, so u minus 1, u minus 4. However, because we got that 2 over here, so we're going to divide that by 2. We're also going to divide that by 2. One of them can be simplified further, which is, in that case, that one, which is 2. And what we do with the 2 that has not been able to simplify further that first number, so we're going to send 2 back to u. So what gives us, that gives us then 2u minus 1, and then u minus 2 as the factors for the quadratic equation. Now, if you remember, so that is going to be 2u, so we're going to say either 2u minus 1 equals to 0, or u minus 2 is equal to 0. So u is equal to half, and u is equal to 2. So remember, u now we're going to bring back x. So u, as we said earlier on, is square root of x. So square root of x equals to half. Now x is the square of half, which is a quarter. And for u equals to 2, that means square root of x equals to 2. So x is the square of 2, which is therefore 4. So the solutions are x equals to a quarter and x equals to 4. So here we go. These are the answers over here, right? Okay. No, sorry. That one is just a quarter. I need to replace this one. Okay, so let's just get on with that one. We're going to replace that by a quarter, which is fine. Okay, so this is a quarter and then 4. Okay, so what we're going to do next now is for you to start practicing to see if you understand it. Here we go. So we got two questions there for you to practice, and I'll see you on the next slide for you to be able to compare your answers with mine. Here we go. And let's see if your answers are correct. Okay, so you can pause the video here, and I'm going to move on and see you on the next concept. Concept number 2, quadratics with geometry. Here's your examiner tip. Draw and label a clear diagram first. Most marks are lost from a missing or wrong expression. Note the algebra. Now, for our first question, we're going to be drawing a right angle triangle. And in this case, we need to draw a sketch of that right angle triangle. So it doesn't have to be to scale. Well, is just put the letters x, x plus 7. All you got to make sure is the hypotenuse has to be placed on the longest side, of course, and this is our right angle triangle. Now, in order to solve this problem, we need to be able to construct an equation. And in order to construct that equation, we're going to apply the Pythagoras theorem. So we're going to apply Pythagoras theorem. And Pythagoras theorem, if you remember, is as easy as A, B, C. So I think you know where I'm going with this equation. A squared plus B squared equals to C squared. And if you do your substitution, A, okay, let's call that A. The first, the shorter ones are A and B, and the longest side is C. Okay, so let's do our substitution then. So that's going to be x to the power of 2 plus x plus 7 to the power of 2, and C is x plus 8 to the power of 2. Now, I'll give you a tip on how to do this one, because you will see that we're going to have to expand to square brackets. So I'll give you a shortcut here, a plus b to the power of 2. We're going to use, this is what we call an identity. So the first term is squared, and then you're going to double the a plus b, which is a times b, and then double it is going to be 2ab, and that then you square b, which is going to be b squared. If you want, you can still do a plus b, a times b, and then square that, multiply those two brackets, and you will end up having a squared plus 2ab plus b squared. So that's a shortcut we are using, and we're going to apply this in that case. Okay, then let's get started with applying this form identity. So x squared, well, just nothing more than writing x squared. This one needs expanding, and the other one needs expanding. So we're going to square the first term, so which is x. So that's going to be x squared. And then don't forget, you have to double x and 7 multiply together. So 7x, double it, is going to get me 14x. And then you're going to have to square the 7, and that gives you 49. On the right hand side, if you square x, you're going to get x squared, and then you double 8 times x, which is going to give me 16x, and then you're going to square the 8, and that gives you 64. Now right away I can see I can cancel the x squared on both sides because they have got equal weight. We can remove these weights on either side. Therefore that leaves us with x squared. Now 14x, now if you send the 16 over there, so that's 14x, take away 16x, plus 49, take away 64, and that gives you equals to 0. When you simplify this x statement, you're going to get, it's going to be not plus, but minus. So it's going to be minus 2x, and 49 take away 64, that gives me take away negative 15, and that's going to be 0. And now I will need to find the factors of 15. So 15, because that's 15 over there, 15, 1 and 15, and then 3 and 5. Now to be able to get the correct factor, we know we got negative 15. To get negative 15 and to be able to get 2, so 1 and 15 will never give me a 2. So 3 and 5 will give me a 2, but bearing in mind that we are going to have to get a factor of minus 15, so plus and minus, to get minus 2 here, you need minus 5 and plus 3. So that combination is going to give me a minus 2. Okay, right, so let's factorize that then, and we're going to get x here and x over there. So we'll pick up plus 3 and minus 5, plus 3 and minus 5. So in that case, you can get x minus 3 or x minus 5 as the possible numbers for x. However, because we know that x is one of the sides, this one is going to get rejected. So we're going to reject x equals to minus 3 because, okay, so rejected as x has got to be greater than 0. So it's not the correct answer. This one is. So we're going to write, so to make it clear to the examiner what our final answer is, x is going to be equal to 5 centimeters. Okay, so we're now going to move on to the next question. In this case, we are talking about a rectangle. So let's sketch this out here. And the rectangle has a length which is 3 centimeters more than a width. So we take the smaller one, let's call the width W, and therefore the length is 3 centimeters longer. We just need to add 3 to W. So we got the length and the width. Now the diagonal, so let's draw the diagonal, and that's going to be 15 centimeters. So everything in centimeters. Now, like in the question above, we applied the Pythagoras theorem. So the Pythagoras theorem requires you to label, label the hypotenuse, okay? And now this time I've chosen A to be the hypotenuse, so it doesn't matter. So the hypotenuse is on its own here, A squared plus is equal to B squared plus C squared, as long as you know that this is the hypotenuse, okay? So we got 15 squared equals to A is W is W, B is W plus 3 squared, and C is W. So let's expand them, these terms. So that gives me 225. And applying the identity that we talked about in the previous example, we're going to get the square of W, so W squared, and then you double the product here. 3 times W is 3W, double that up, and you're going to get 6W. So 6W will give me, it will be followed by the square of that, and that gives me 9. And here, don't forget, we have to square that too, so that's going to be W squared. Now, W squared and W squared, that adds up to 2W squared. We're going to get 6W here, plus 9 minus 2 to 5. And that is a 0 here. So 0 is 2W squared plus 6W. And I think that is going to be 216 minus 216. And that's your quadratic. But you can simplify that by divide by 2. You're going to get 0 equal W squared plus 3W, and then that's going to give me minus 108. And okay, so 108, we're going to have to look for factors of 108. So factors of 108, let's write it here. So 108 is 1 times 108, 2 times 54, okay? And what if I use a 3? So we don't know what's that going to give me with 3. So let's do a division. 108 divided by 3. 3 in 10 is 3, remainder 1. So that is 3 times 36. Now, none of these will give me a 3 that I'm looking for here. So let's do 4. And I don't think 4 is going to work. We've got to get closer numbers. So 4 is not going to work, and 5 is not going to work. Let's try, is 6 going to work? So if you make that 6 here, 108, 6 in 10 is 1, remainder 4, 6 and 18, 6 and 18 is not going to work. Okay, so what we're going to get is after 6 is 8 going to work? no, 8 is not a factor. So let's try 9. So 9, okay, so we got divide by 9, 108, so 1 here, that's 12. So you can see 9 and 12 are going to give me 3, okay. So if I write 9, okay, so 9 and 12, to get a positive 3, you have to have plus 12, take away 9, okay. So let's write it as 9 and 12. Okay, so that's going to be W, okay, W 9 and 12. And as we discussed earlier, it's going to be a plus and a minus. And W is equal to 9 or W equals to negative 12, which is going to get rejected. And in that case, we're going to go for W is 9. We're going to write down the solution as, so W is equal to 9 centimeters, and the length is 3 centimeters longer, which is therefore going to be 12 centimeters. So length is 12 centimeters, width is 9 centimeters. Now it's time for you to start doing some practice questions, and let's see what we got in store for you. For this question, for this one, you got two questions, but it's to do with circles and right angle triangle. Let's see if you can try them, and I'll see you on the next slide. Okay, so you can pause here as well and see if which ones did you get correct and which one you can correct. Mistakes you can correct and annotate on your work. Okay, time for us now to move on to concept 3. Concept number 3, the discriminant and algebraic proof. Now this is for clearly grade 9 questions. Here's your examiner tip. Compute b squared minus 4ac and compare it to 0. You don't need to solve the equation to answer a show that question about its rules. So this concept of b squared minus 4ac is in fact a term, we use a term here to actually represent that formula. So that term is actually known as the discriminant. Okay, so this is why the word is used here. So discriminant, I can use the letter D to represent that formula, b squared minus 4ac. So what the discriminant tells us is whether, now you're going to see here, we're dealing with quadratic equations. So quadratic curves may cross the x-axis. In that case, you're going to get what we call roots, two roots. So we're going to get two roots in that case, two roots. Or we can get simply just one root, and the way it works is like that. And so which means that the x-axis is only touching the curve at one point. So in that case, we get one root, or we can say it's repeated. So one root. Or sometimes you may have the curve not even touching the x-axis. And I'm sure by now you will have guessed it right, so you have no root at all. No root means there's no crossing point for the curve on the x-axis. Now, in order to distinguish, hence the word discriminant, in order to distinguish this, we'll use this formula. So even we do not need to factorize, we don't need to use the quadratic formula to be able to work out whether we got two roots. Now, so that formula is going to rely on your understanding that you have to use ax squared plus bx plus c to present that equation. It's the general equation for quadratics. So knowing the values of a, b, and c, you should be able to apply this formula. So d is equal to b squared minus 4ac. So you substitute values in there and work out the value of d. Now, if d is a positive number, that means greater than 0, then you know you have two roots. Now, if d gives you exactly 0, then you know you're going to get just one root. And if d is less than 0, you don't have any root at all, so you cannot factorize, you cannot use the quadratic formula to get a number. You can try, but you are not going to get any value. So this is what we're going to try to do here. Now it says it has no real roots. It says show that question. To show that show that question, all you got to do is prove that the discriminant is less than 0 or a negative value. So let's try to work out what the discriminant gives us. In that case, a equals to 1 by comparison with the equation, b is equal to 4, and c is equal to 7. So using the formula, d is equal to b squared minus 4ac. And what do we get here? So b is replaced by 4, a is replaced by 1, and c is replaced by 7. So let's work it out. So that is 16 minus 28. And 16 minus 28 gives us negative 8. Negative 8. Yes. No, that's not negative 8. It gives us a negative 12. Sorry, that's a negative 12 minus 12. But that therefore means that this is all the way less than 0. So being less than 0 means that the discriminant is a negative value. Okay, and if the discriminant is a negative value, since d is less than 0, we can say the equation x squared plus 4x plus 7 has no real roots. That's a conclusion we need to write. Okay, every show that question requires a conclusion, so conclusion is required. You don't need to write the word conclusion, but it's for me to put an emphasis here that you need to write a conclusion. Okay, moving on to question 2. Now prove that x squared plus minus 6x plus 2 plus 10 is always positive. Now over here we can use the discriminant method. We got to prove that the discriminant is less than 0. Why? Because the curve is always going to be above the y-axis, so therefore that is going to be positive, and therefore discriminant will be positive as well. Okay, so what we're trying to do is the discriminant, either we use the discriminant method or we can use the completing the square method. So let us see if we can choose the discriminant method or so using the discriminant method. Okay, so b squared, so we're going to work out b squared minus 4ac. Now a is equal to 1, b is equal to negative 6, and c is going to be equal to 10. So let's do b squared. So minus 6 squared, 4 times 1 times 10, and that is going to give me 36 negative 40, and that gives you negative 4, which is less than 0. So since discriminant is negative or less than 0, we're going to say x squared minus 6x plus 10 is always positive, because the curve never goes below the x-axis. It's always positive. Now the other method is find, okay, the turning point method. So if you are to prove this via the turning point method, which is not the case we're discussing, so what you got to do is try to work out the turning point using completing the square. Use completing the square to find where the minimum is. Okay, So use completing the square method. So completing square form. So y is equal to x minus p squared plus q. And you got to prove that the turning point PQ, so x, y, so the y value, this is the y-axis, so the y value, which is q, has got to be positive. So that's the other method. Okay, so let's see if you can try to answer questions on the right hand side of that screen, and here you go. And let's see, you pause here, and I'll see you on the next slide to show you the answers. Okay, all right, all the best. You can pause here again and check your work. Concept number 4, multi-step extended problems. Examiner tip. Break the question into stages on paper, form the expression, simplify, and solve. Don't try to do it all in your head. Now, the first question says the nth term of a sequence is n squared plus 3n. Find n when the nth term is 88, and that's a question that's worth 4 marks. So let's get started with defining what the term n is. Okay, so the term n is defined as, so this is the nth term, n squared. It's done for us anyway. It says the nth term is equal to 88. So let's make it 88. Okay, so the nth term is 88. So what happens? How do you find the value of n? So the way we're going to do this, of course, when we solve a quadratic equation, you have to have 0 on one side. So we're going to send 88 onto the left-hand side. So we got n squared plus 3n minus 88. Now we're going to be looking for factors of 88. So factors of 88. So 88 is 1 times 88. Now remember, we need to get a difference of 3. So let's look for the next one. 2 and 44. We can't get 3. Multiple of 3, a factor of 3 in there. So we're going to do 4s. That's 4 and 22. You're still not going to get 3, a difference of 3. So you can't do 5, you can't do 6, you can't do 7, you will do 8, 8 and 11. Yeah, that one gives you a 3. To get a positive 3, you need positive 11, take away 8. So therefore you're going to factorize this as follows. So you're going to get minus 8 in here and plus 11. So either n is equal to 8 or n is equal to negative 11. Now, why is it part of a multi-step extended problem? It is because you are going to get it further at the bottom of questions. When there are long questions, you might get it at the end. This is a discriminant in terms of the ability of students. So, and yeah, so getting back to that question, n is equal to 8, n is equal to negative 11. Now, nth term, n cannot be negative, so we're going to say rejected in that case, rejected, and the reason is n has got to be greater than 0. So your solution is this. So n is equal to 8, and it's the 8th term. Now the next question says two numbers differ by 5. So one is greater than the other by 5. So we're going to say, let's start with, let the numbers be n and n plus 5 respectively. So we got n to work with and n plus 5. Now then it says the sum of their squares. Now this is a hidden quadratic, isn't it? So sum of their squares. So sum of squares is square of the first one and the square of the second one. The square of the second one gives you n plus 1 squared, and that is equal to 2, 3, 3. Now, in case of the square of n plus 5, what we're going to do in that case is we are going to get that expanded using the method I've shown you earlier on. Okay, so we're going to square that first one, so which gives me n squared, and then we're going to double this 5 times n, which is 5n plus 2 times 2 is 10, n plus the square of that is 25, and then you got 233, which you're going to send onto the left hand side. So you're going to get 2n squared plus 10n, and so you're going to get 233, take away 25, and that gives you 104. Right, so that is 2, that's 1, yeah, that's 4, 204, 208, sorry, that is 8, and you should not, you should write 8, you do not write over a number, 208, so that is negative 208, and then you divide by 2 throughout, that gives you n squared plus 5n minus 104 equals to 0. Okay, and then you're going to have to look for factors of 104. Factors of 104. So 104. Now remember, we're looking for a difference of 5 in that case between those factors. And so 104. So if you keep going from 1, okay, 1 and 104, you keep going down, you will come to a point where you're going to get 8 and 13. Okay, so it's quite a long way. I'm just trying to save some room here. So 8 and 13. To get 13, you need a plus here and a minus. So that makes it plus 5. Okay, so factorizing then is going to give me n minus 8, and then n plus 13, and that all together equals to 0. So n is equal to 8, n is equal to negative 13, which therefore, are we rejecting any number? Two numbers? No, we don't need to reject anything because there's no restriction on the numbers. Okay, we can think of a number that can be negative as well. So we got two answers, and here we go. So we got 8 and minus 13. Okay, there you go. Answer done. So it's your turn now to practice questions on the second half of that slide. So here we go. Right, so I'll see you on the next slide. You can pause the video here, okay, and see you soon. Okay, hopefully you've been able to attempt those questions and got my answers there and check if you got them all right. Okay, now we got some takeaways from this session. So key takeaways from part 3. First of all, substitution turns a disguised quadratic into one you already know how to solve. Secondly, in geometry problems, translate the diagram into algebra before you touch the quadratic. Then the discriminant answers how many roots without solving the equation is sometimes the way to prove how many answers you get: 2 roots, 1 root, or no root. And then you have extended questions that reward a clear stage method. You go to form, simplify, solve, and interpret the answers. Coming up in more topics. So you got more grade 8 to 9 series of they are on the way. I've got simultaneous equations coming up, cycle theorems, trigonometric identities, are all in the same three-part format. Okay, so I hope you enjoyed this video. Please like, share, subscribe, and comment. Your feedback will always help me create more videos like this. Okay, so see you soon on another video. Okay, take care. Bye bye.